So we're on our sixth set of notes, and that's about straight line pairs and vertical angles. So up to now, when we've learned about angles, I've taught you 3 ways we can describe 2 angles, right? So when we have sentences, like for example, if I wanted to say, the girl is pretty, pretty is a descriptor word. It's how we're describing the girl. There's an S there. Describing the girl, right? It's called technically an adjective. I can't spell that. Okay? What we're talking about, though, what it is that is pretty, is the girl. This is the noun. What it is. Okay? So far, we've learned 3 ways to describe angles. So congruent meant they were the same. Okay? Complementary meant that they added to 90. And supplementary meant that they added to 180. So those are ways we can describe angles. The next few lessons, we're going to learn different types of angle pairs, the nouns, what they are, right? So what this means is one type of angle pair relationship is if 2 lines are a straight line pair. In order for 2 angles to be a straight line pair, together they must make a straight line. So 2 angles that make a straight line. Note that in this picture, this angle, LMP, so angle LMP, and this angle here, PMN, and when you put the 2 together, they make this straight line. Angle PMN are a straight line pair. But here's the things about straight line pairs. Straight line pairs are one of these 3 words. Well, a straight line is 180 degrees. So straight line pairs do add to 180, so they are supplementary. That's how we describe straight line pairs. We say straight line pairs are supplementary. Okay. The next type of angle pair that we can have are 2 vertical angles. Okay? So vertical angles are angles across from each other. Okay? So, and don't write this part, but if this was angle 1, 2, 3, 4. When I talk about angles that are vertical to each other, meaning straight across, 1 and 3 are vertical angles because they're straight across. And then 2 and 4 would be vertical angles because they're straight across. Okay, so if I'm writing this out, I'll start with 1 and 3, angle AED. So this guy right here, angle AED. To this one right here, angle CEB. So this guy in here, CEB. These guys are vertical to each other. They're vertical angles. Also, there's also angle AEC. So angle AEC and angle DEB are vertical to each other. Angle DEB. So 2 and 4 are also vertical angles. And here's a special part about vertical angles. There's a rule that says vertical angles are always congruent, meaning they are the same. So it means I can put 1 tick through 1 and 3 because they're the same, and then 2 ticks through 2 and 4 because they're the same. Okay? So vertical angles are congruent. Well, straight line pairs make entire sense. Straight lines are 180. Supplemental means they add to 180. So of course you believe that straight line pairs are supplemental. But do you really believe right now that vertical angles are congruent? They're always the same if they're across from each other? Well, in case you don't, I'm going to prove it to you. When it comes to proofs, I'm going to prove all of these. So if I ever say vertical angles are congruent, we have to show you why that's true and prove it to you. However, there is only one proof of this. So I'm not going to ask you on a worksheet, like, prove it's true because you already have it in your notes. However, a test might expect you to be able to prove something. So you have to understand the proof and know why it works. So let's just use this picture. It has angles A, B, and C. It doesn't talk about this one. So what I know by looking at it, according to my conjecture, because I'm just telling you right now that vertical angles are congruent, right, is that the two that are congruent right now are B and C. So at the end, and I'm going to write at the bottom what I'm trying to prove, and I'm going to use a flowchart proof. I'm going to try to prove that B, angle B, is congruent, the exact same, and we don't put just equals for congruent, we put this little tilde mark, and it means congruent to angle C. And somehow I want to prove this at the very end. Okay? So then, what do I know? What's given to me? What do I know for sure? Well, I can use the fact that straight line pairs are supplemental as a fact. Okay? And do I have a straight line pair? Well, look at A and B. Together, angle A with angle B make this straight line. So I know that angle A plus angle B have to equal 180. And how do I know that? Well, because they're a straight line pair. Right? So they have to add to 180 because together they make a straight line. Well, in the same way, if you look at it this way, angle A and angle C also make a straight line. So I could say that angle A plus angle C also add to 180 because they're a straight line pair. Okay? Well, algebraically, if this equals 180 and this equals 180, if they both equal 180, then they have to equal each other, right? They have to be the same. So I could say that angle A plus angle B has to equal 180, but also 180 equals this, so it has to equal angle A plus angle C. And I did that because they both equaled 180. They both equaled 180 degrees. So since they both equaled 180, I could say they equaled each other. So because this equaled 180, and because that equaled 180, I could say they equal each other. Well now, if I want to go from here to here, right? There's a very small difference. On the left of my equal sign, I have angle A plus B. Over here, I just have B. So I want to get rid of this A. So to do that, mathematically, I would minus this A away. So I'm just left with angle B. But then when I minus the A away over here, I'm just left with angle C. So this does equal this because of subtraction. Because if I subtracted A away from both sides, I would find out that angle B was equal to angle C. So basically, what this means with numbers, that makes it a little easy. If I say A is 50, well, for this straight line pair, it has to add to 180. So B has to be 130. But also in this straight line pair, this also has to add to 180. So C has to be 130. Which means if this equals 180 and this equals 180, when I subtract the A away from both sides, you just see that they're both 130. because it has to be that way in order for them to make straight line pairs, which means they'll always be the same. Just like this will also be 50, because with the 130, or with this 130, it doesn't matter. To get the straight line pair, it's going to be 50. So because of the straight line pairs, we can prove that vertical angles are always congruent to each other. They're always going to be the same. So then, using everything we've learned so far, this is about what your test is going to look like. And it's very complicated, and it's a lot of work because you have to combine everything you know into one. So what they're going to do is they're going to give you a picture like this, and they're going to tell you some of the angles, like, you know, this one's 35 and that one's 110. And they want you to tell me all the angles you see in the picture. So here's the rules. You can only start with what's given to you. You can't just decide something's true. You have to prove it first. But once you prove it, and you know what an angle is, you can use it as a given fact for the other angles. Okay? And so this one's a small one. Normally they're much bigger. But we're going to start, and I listed all 5 angles in the picture because I see them all. Here's 1, 2, 3, 4, and 5. Usually you're going to have to come up with the angles by yourself and make sure you have them all. Okay? But I wrote them in a logical order to save us some time. So I'm going to start with, I have no way to figure this out. No way to figure this out. I know what that is. Can I figure this one out? Well, it's on a straight line. This guy here is on a straight line with 110. So I'm going to start with 110. Angle ECD, this guy here, ECD, was 110. And I know that because it was given to me. They just told me it was 110. So then angle, this one here, angle ECB, is a straight line pair with this dude, with 110. And if it's a straight line pair, it has to add to 180. And so if I do 180 minus that 110, I find that this one has to be 70. It has to be 70. How do I know that? Because this angle, the one before, angle ECD, and the angle I'm on, this yellow one here, angle ECB, are a straight line pair. And that's how I know. And because they're a straight line pair, they have to add to 180, so what's left is 70. Okay? Well, I now know that this is 35 and this is 70. Can I figure out either one of these? I can figure out this one now. I can figure it out because remember there's a rule with triangles, this is from 2 notes ago, that say the 3 angles in a triangle have to add to 180. So if they have to add to 180, I have 70 plus 35 is 105. 180 minus that leaves 75 left for this angle. So it has to be 75. Okay? So, but before I could even figure that out, I had to list that I knew that angle E was 35 because that was given to me. So now that I've proved the 110 because it's given, the 70 because of the straight line pair, written the 35 that's given, I can now say that this one is 75. I had to say the other 2 first. I had to know this one and this one before I could do this one. Because the only reason I know this one is because angle E, angle ECB, and this angle I'm on, this guy right here, angle EBC, are in a triangle which adds to 180. Okay? And now that we know what angle EBC is, we can finally get angle ABE, this one here, because angle ABE with this inner angle EBC form together to make a straight line pair. And so I know, since they're a straight line pair, that it has to add to 180. So if I do 180 minus a 75, that's this angle right here, I'm left with 105 degrees to be angle ABE. So angle ABE I just found to be 105 because angle EBC and this angle I'm on, angle ABE, are a straight line pair.